Hello friends, in this problem, a circuit is shown in the diagram and now it is given that the switch S is initially open and the capacitor is initially uncharged. Now if I1, I2 and I3 represent the current in the resistances of values 2, 4 and 8 ohm respectively, we have to find the values of I1, I2 and I3 just after the switch S is closed, as well as the current in these three wires or the three resistances after a long time. So we know that just after the switch S is closed, capacitor effectively will behave as a conducting wire. So if we draw a new circuit diagram, let us first write the condition that just after the switch is closed, we know that capacitor behaves as a conducting wire. So I am replacing the capacitor with a conducting wire, and the new circuit is redrawn. The value of these resistances were given as 4 ohm, 8 ohm and 2 ohm. The value of EMF was 6 volt. Let us again mark the values of current in the three resistances as I1, I2 and I3. Now as mentioned, I am replacing the capacitor with a conducting wire. So it is clear that the value of I2 as well as I3 will be 0. The value of I2 as well as I3 will be 0 since both these resistors are initially now short circuited, and the value of I1 will be equal to 6 divided by 2, that is 3 ampere. So this is the condition just after connecting the capacitor to the circuit, and this matches with option B. Now further we know that after a long time we know that the capacitor will behave as a open circuit. The capacitor, these two capacitors, as you can see over here, this 2 microfarad and 4 microfarad capacitor will behave as an open circuit. So if they start behaving as an open circuit, current in I2, that is current in 4 ohm, will be 0. So I can directly write after a long time I2 will be equal to 0, and hence the value of I1 and I3, as now these two resistors will be connected in series, will be equal to 6 upon 2 plus 8, that is zero point 0.6 ampere. So this is our final desired result after a long time of closing switch S. Thank you.